Alright, this is an attempt for recording Perms and Comms lesson number 2 for Rob Shaughnessy's class. As you can see, the standard disclaimer, please attend class rather than watching the videos all the time. But otherwise, this is Perms and Comms number 2. Now, hopefully this works. Permutations, okay? Permutations is actually similar to what we were doing yesterday, okay? It's a fundamental counting principle. It still involves arranging objects. You're putting them in set orders, you're putting them into positions. The only thing about permutations that really stands out is there's just no option of repeating an element. Now, permutations gives you a little bit more flexibility and actually takes a little bit less time to write out. But really that's what it boils down to, is it's not a whole heck of a lot different. Now with permutations, okay, what goes with this is you can have a variety of different permutations. Now one of the permutations, one of the possibilities that you can have, the format and everything looks like this. It's NPR. Okay, N pick R. This is the number of permutations of n objects taken R at a time. Okay, so you have n objects to choose from, and you're taking and arranging R of them. Now obviously R has got to be less than n. Okay, you can't do that, otherwise this makes no sense. And the reason it makes no sense is, think about if you've got 10 pencils and you want to take 12 of those 10 pencils and arrange them. Well, you can't do that. Okay, you just can't. So R has to be less than n. The number you're selecting has to be less than however many you have. Now what goes with this is there's a formula. N pick R is n factorial over n minus R factorial. Okay, so you've got the factorials going on, same as we had yesterday. Now with those factorials, that's a formula. Basically it's, take the number of objects you have, factorial them, and then divide by the difference. Now once you've got this sort of idea, then the idea here holds. Now this next one here, determine the number of distinguishable arrangements of all the letters of the word syrup. Okay, well, there are 5 letters in syrup, so if I do it with the fundamental counting principle, what we were doing yesterday, what we do is we think, well, there are 5 blanks, and there's 5 options for that first letter. Once I've chosen that first letter, then there are 4 options for the next, then 3, then 2, then 1. Keeping in mind I've got to go through and I multiply them out, I'm going to get 120. Okay, what this allows me to do, though, is I can say, well, rather than writing all that out, I've got 5 letters and I'm going to arrange or pick all 5 of them. 5 pick 5. Now doing it by hand, what I'd get is n is 5, so 5 factorial over n minus r. Well, n is 5 minus r is also 5 factorial, and what I get is 5 factorial divided by 0 factorial. Now remember, 0 factorial is that special case. It's equal to 1. So what I end up with is 5 factorial, or 120. Okay, so you can do both, and often they work together. Which is best? Okay, it depends on what you want. Okay, you have to know both, because each are going to be used on an exam. So I'm going to try to do a whole variety of different things. Now what I quickly want to do is I want to show you about how to evaluate that on a calculator. So there's our standard TI-84, all that jazz. And you turn it on, it's got all sorts of calculations. Okay, and so what I do is I want 5 pick 5. Well, 5 I can enter, and I want pick 5, or permutations. Push the math key and scroll over to the right till I get to probability, and there, NPR, it's the second option. Okay, so 5 pick 5. That gives me 120, which is what I wanted. If I have a newer calculator, I can turn on the classic mode or the math print mode. It ends up looking the same. So we've got that. Okay, so that's how to get to permutations, and you can do anything. 10, pick 3, okay, 720. You can do all of those different ones going through. The light's getting in the way, but you can do any of those just in the calculator. That's an easy way to write it out. A toddler is arranging 6 DVDs on a shelf at random. Okay, so he's just doing it in random. How many possible orders can be made? Well, keeping in mind I could think fundamental counting principle, there are 6 blanks, or I can say there are 6 DVDs and I'm picking or arranging 6 of them. So I get 6 pick 6. And when I do that, that's going to be 120 times 6, I'm just doing the math, 720. So there are 720 different possibilities for arranging those DVDs. This one here, Sally has flags of 8 different colors, and she needs to arrange them in order to make a code. So what we've got is we've got 8 flags to pick from, and we've got to pick 3 of them. So I go 8 pick 3, that's all I have to do. And if I do 8 pick 3, and I'm just going into my calculator and doing that, I get 336. So there are 336 codes that Sally can make with these 8 flags. Okay, they're all different colors. And what we end up with is we end up with a whole variety of these things. Okay, if I look at the next ones here. Brandon is making a 5-digit code for his smartphone. How many codes are possible if you are allowed to repeat digits? Now, keeping in mind, fundamental counting principle allows you to repeat digits. Permutations does not. So if I'm allowed to repeat digits, this can't be permutations. I've got to say, well, I've got 5 blanks, and once again I'm back to the fundamental counting principle. Okay, I've got 10 choices for that first digit, and I'm allowed to repeat them, so I've got and 10 more, and 10 more, and 10 more, and 10 more. And if I multiply them out, that's going to be 100, 1,000, 10,000, 100,000. There are 100,000 possible codes. Okay, if I have no repetition of digits, okay, so I'm not allowed to repeat digits, well, in this case I could do 10 times 9 times 8 times 7 times 6 and so on and so forth, or I could also recognize that I could write that as 10 pick 5. I've got 10 digits to choose from. I must pick 5 of them, and if I do that, that's 10 pick 5, and I'm just going to my calculator again. That's 30,240. So if I'm not allowed to repeat digits, there are only 30,000 of them. And this works with kind of what we expect and kind of what we think about, is that as we get more and more restrictive, we have fewer and fewer options. Okay? C, you are not allowed to repeat digits. This is the same thing. So I'm going to change this. You're not allowed to repeat digits, and it must end in an odd number. Okay? So if you're not allowed to repeat digits and it must end in an odd number, this is kind of one of those odd situations where you end up using kind of both. You've got the first 4 and you've got the last digit. Now with the last digit, you've got 5 choices: a 1, a 3, a 5, a 7, or a 9. There are 5 choices for that. Now I need to come up with the other 4 digits of this 5-digit code. Now if I'm not allowed to repeat them, I've got 9 to pick from, and I've got to pick 4 more. So I end up with 9 pick 4 times 5. And if I do 9 pick 4 is 3,024 times 5 is 15,120. Okay? So we end up with that. Now this isn't really a surprise. I had 30,240 if I'm not allowed to repeat. Here I'm still not allowed to repeat, and I'm looking for odds. Well, you know that half the numbers are odd, so you could have done that too. But nonetheless, you've got that sort of idea. Next example. Peter is a member of a club with 11 other people. Peter is a member of a club. The club plans to select a president, a vice president, and a treasurer. No person can have 2 positions. The number of possible selections if there are no restrictions. Well, when I'm putting them into particular orders, I'm putting them into particular ranks, I'm putting them into particular positions, that's a permutation, because putting Peter as president is different than putting Peter as vice president or putting Peter as treasurer. So I've got those sort of options. If there are no restrictions, there's Peter plus 11 other people, so there are 12 people to choose from, and I've got to pick or arrange 3. And so I end up with 12 pick 3, and once again, just calculating that, that is going to be 1,320 possibilities. So there are 1,320 possible ways that this whole thing can be done. If Peter has to be president, then I've got the president plus 2 others. Now, that's others, OT, okay? The president, well, there's one choice for president. Peter. That's it. So if I'm saying Peter must be president, then there's one choice for president. Now, I've got 11 other people to pick from, and I've got to pick 2 of them. So I end up with 1 times 11 pick 2. So 11 pick 2, 11 pick 2 is going to be 110. So there are 110 of those 1,320 committees. 110 of them have Peter as the president. Also, too, keeping in mind some things that can happen. Peter must be selected for at least one of the positions. So what I've got is that the Peter is president, or, now or means add. Peter is vice president, or I've got Peter is secretary. Or sorry, treasurer. Okay, so I've got those situations. Well, if Peter is president, it's this situation. So I've got the president and 2 others. 1 times 11 pick 2. Or Peter could be vice president. Well, once again, I've got a VP blank and 2 others that I've got to fill. This is still 1 times 11 pick 2. Or I could have Peter as treasurer. Well, this case I have a treasurer blank and 2 other people. So it's 1 times 11 pick 2. So really it's just the same question a couple times. I've got this idea that there are multiple cases. If there are multiple cases, I could do this or this or this. In that case, what I've got, no pun intended, in that particular situation, in that case, I've got to add my different cases together. So in each one I get 110 plus 110 plus 110, or 330 possibilities. And that's my options there. So that is permutations. Now, that's just a quick introduction to permutations, but hopefully that'll lead you through some of the homework. If you have any questions, let me know, and please try to come to class next time. Thank you. Bye-bye.